Okay, we've been talking about calculating confidence intervals for proportions. Here's another example. A random sample of 250 adults in a medium-sized college town were surveyed, and it was found that 110 were regular voters. Estimate the true proportion of regular voters with 90% confidence. Now, before I go through the formula on this example, let me show you the graphing calculator shortcut. If you have a graphing calculator, one of the functions it has built in is something that will do this calculation for you. So let me show you how that works. So we need to push the Stat button and go over to Tests and use the arrow button to go down to, at least on this model of calculator, it's choice A. It says 1 prop z int. Prop for proportion, and this is a z interval. When I select that, it's going to ask me for three numbers: x, in, and the confidence level. So x, in is the sample size, so that would be 250. And x is the actual number out of those 250 that fall into the category we're talking about, in this case being regular voters. So in this example, it was 110 out of 250. So x would be 110, in would be 250, and the confidence level is 90%, so that would be 0.90. Then I just go down to calculate, hit enter, and it gives me the interval 0.38836 to 0.49164. So that's about 38.8% to 49.2%. And it also tells me that p hat was 0.44. Now let's go back and do it the old-fashioned way, just using the formula. What did we say in was? 250. That's the sample size. That's how many individuals there are altogether in your sample. What is p hat? Well, the calculator just showed us, but if we hadn't done that, we would calculate p hat by taking 110 divided by 250. And then q hat would be 1 minus 0.44, sorry, a little typo there, which is 0.56. Now here the division came out even. It came out to be exactly 0.44. But if we had had more digits after that, I would want to keep at least 3 digits after the decimal point in my number for p hat if I'm going to get at least 3 digits in my final answer. So in this example, we didn't have to worry about rounding because it just came out to be a nice even 0.44. But sometimes if you get more decimal places than that, make sure you keep at least as many as your final answer is going to have. And we're doing a 90% confidence level. So the number we use for z sub alpha over 2 is 1.65. If you don't remember that, look that up on your 7-1 notes. Now let's put this into the formula. .44 minus 1.65 times the square root of 0.44 times 0.56 divided by 250. So that's about 0.388. And then the same thing, but if I go back and change the minus to a plus, it's 0.492 rounded. So I can say P is somewhere between 0.388 and 0.492. I don't know that absolutely for sure, but I'm 90% confident about that. Now let's talk about sample size. Let's say that you have not done your survey yet. You haven't gone out and asked a bunch of people whether they own a yo-yo or who they support or what cola they like. And so you're still in the planning stages and you're trying to figure out how many people you need to survey. How big a sample do you need to have? And that's going to depend on your confidence level and your margin of error or maximum error of the estimate. Do you need to know to within just 10%, 5%, 2%, 1%? How much do you need to narrow things down? So based on your answers to those two questions, here's how you decide how big the sample size has to be. The formula for sample size for a proportion looks like this. N equals P hat times Q hat times Z sub alpha over 2 over E squared. And then just like with sample size for means, this usually won't give you a whole number answer, but what it does give you, you have to round that up to the next whole number. You have to have a whole number of people in your sample. And so the number it gives you, if it isn't a whole number, you don't want to round down because that might give you a sample that's too small. But if you round up, your sample, it might be a little bigger than it absolutely has to be, but that's okay. It's okay for a sample to be bigger than it has to be. You just don't want it to be any smaller than it has to be. Now, something a little odd about this formula is that to use the formula, you have to have numbers to put in for P hat and Q hat. And those numbers are what you get as the result of doing your survey or looking at your sample. But if you're still trying to decide how big the sample has to be, you don't have your sample yet, so you don't have numbers for P hat or Q hat. So one of two things is going on. You handle that in one of two ways. One way is maybe you have some idea of what those proportions are based on a previous study. Maybe that previous study is a little bit out of date. You want to see if the numbers have changed. Maybe that previous study didn't have a big enough sample for the kind of accuracy you want, but you have some information about how big those P hat and Q hat are. So if you have that, you would go ahead and use those numbers for P hat and Q hat in the formula. Otherwise, if you have no idea what the proportions are going in, then put 0.5 for P hat, and then Q hat would be 1 minus 0.5, which would also be 0.5. So that kind of gives you a worst case scenario. That gives you a sample size that is bigger than it would be for any other numbers you could put in for P hat or Q hat. So it might be bigger than it has to be, but at least you know it's big enough. And remember the number you put in for E, sometimes it's expressed in percentage form, like we want to know to within 5%. But when you put it into the formula, make sure you put it in as a decimal, like 0.05 or whatever. So in our yo-yo example from earlier, the margin of error turned out to be 0.122 approximately. And so we found out to within a little over 12% what percentage of Lincoln College students own a yo-yo. Well, I just made up the number, so we don't really know, but if I had really done that survey, we would know to within 12%. But let's say we want to narrow it down further. I want to know to within 10%. How do we calculate that? Using the information that we already had. We did find that it was 13 out of 50 from that survey that we did. We were using a 95% confidence level, so our z sub alpha over 2 was 1.96. And in that earlier survey, our p hat was 0.26 and our q hat was 0.74. And to be within 10% means E, the margin of error, is 0.10, 10% expressed as a decimal. So plugging those numbers into the formula for sample size for a proportion, n equals 0.26 times 0.74 times 1.96 over 0.10 squared. So let's go ahead and calculate that. .26 times 0.74 times parenthesis 1.96 divided by 0.10, close parentheses, and I'm going to push the squaring button, and so only the things inside the parentheses are getting squared. And that came up as 73.912 something. So our final answer, we have to have a whole number. We can't go out and survey 73.9 something students. We have to have a whole number of students. And we always round up to make sure we have enough. So rounded up to the next highest whole number, 74. We need to go out and get a sample of at least 74 students to ask them if they own a yo-yo. Now, what if we had no idea what the proportion was? We hadn't already done that previous survey. We had no data whatsoever, no idea going in what the percentage was. Then we use the formula, but we put in 0.5 for p hat and 0.5 for q hat. And it looks like this, 0.5 times 0.5 times 1.96 over 0.10 squared. So 0.5 times 0.5 times parenthesis 1.96 divided by 0.10 squared. Now that came out as 96.04. And we always round up, even though that's a lot closer to 96 than to 97. The rule is for sample size, we never round down because that might give us a sample size that was too small. We always round up. So in that case, you would go out and get a sample of at least 97 students. 97 is the answer to the question, how big a sample do we need? Okay, I'll do one more example of one of these sample size problems, but I'll save that for the next video.